guys, let's finish up our experiments this week with experiment 5.2, cellular respiration and fermentation in yeast. So the purpose of this experiment is to observe cellular respiration and fermentation in yeast, hence the name. So think about, what do you think is going to happen with this experiment? You are going to be taking yeast and adding yeast and some sort of liquid to each of these 3 bottles. You will be putting a balloon over the top of the bottle, and we'll be measuring the balloon to see which mixture inflates the balloon the most. So let's walk through the materials you'll need for this experiment, and hopefully we'll walk through the procedure and it'll all be relatively quick because we're trying to keep the water warm. So first of all, you need 3 travel size bottles, and the procedure recommends that you have 2-ounce bottles, but I can't find 2-ounce bottles anymore. It seems like all the travel bottles tend to be 3 ounces. So, so these are actually 3-ounce bottles that I purchased. You need baker's yeast. We're using Fleshman's active dry yeast, which right now during our COVID situation, it is hard to find yeast, so this is all I could find. So this is what we're using. We are using apple cider, not apple cider vinegar. So this is the apple cider that we're using this time. It is River Ridge Gala Blend 100% apple cider. I let this apple cider sit out till it was room temperature, and then actually just put it in this bowl of warm water to try to warm it up. So all these mixtures are supposed to be warm but not hot, because if it's too hot it will kill the yeast involved. So you're going to need sugar for this mixture, water and sugar, and 50 milliliter graduated cylinders. I actually just went ahead and got 3 so I didn't have to wash them out each time. A funnel, and 3 7 to 9 inch latex balloons, a ½ teaspoon measuring to measure out our yeast, and a ½ for our sugar, and a tape measure or some sort of string that you could wrap around the balloon and then lay it down on a ruler to see how big your balloon actually gets. So the first thing we're supposed to do is stretch out our balloons to make sure that they can easily inflate. Okay, we're supposed to mark each of the bottles with a 1, a 2, and a 3. I've pre-done that. We are supposed to set each bottle using the following instructions. So our first bottle 1, we're going to pour in 50 milliliters from our graduated cylinder. We are going to put in a ½ teaspoon of yeast, and actually before I do that, I guess I'm going to dry out my funnel because I didn't think about how that'll be wet and not all my yeast will go down. And I spilled just a tad of yeast, so let me grab a little bit more, so that we have it all even for each one. So we're going to put on our yeast, and then we're going to quickly put on our balloon. And we're going to shake it around a little bit, okay? Okay, next we're going to do, for our second bottle, we are going to take our warm water, 50 milliliters again, we are going to put in a half a teaspoon of sugar, a half a teaspoon of yeast, in there, put our balloon on, stir it around. So this is our bottle 2, and then lastly, we're gonna put in our apple cider that's been sitting in a warm bowl of water. We're gonna put in our half a teaspoon of yeast. Okay. Swirl it around also. Okay, so now, let me straighten that balloon a little bit. We are going to see which of these bottles inflates the balloon the most. I feel like this, there, balloon wasn't exactly centered over. Okay, so let me set my timer. And let's see what we have. So we've got in bottle 1, just warm water and yeast. In bottle 2, warm water, yeast, and sugar. And bottle 3, apple cider and yeast. So we swirled them around. Okay, so predict what you think is going to happen. Which balloon do you think is going to have the most inflation of its balloon? Make sure that you are recording your observations of the balloons. During and maybe at the end. Don't allow the mixture to spill into the balloon, so you can keep swirling the bottles, but don't let the mixture splash up inside of the balloon. They recommend that you create a data table to record your initial measurement of the circumference of the balloon. So I guess we should measure them now. So right now, the first balloon is 4 inches. The second balloon is 4 inches. And the third balloon is more like 3 inches. We'll check the circumference in a few minutes and see if we have a difference. So that was at 2 minutes. That was the circumference of each balloon. Let's swirl. So in 2 more minutes, we'll check the circumference. So we will check our balloons after 4 hours, and and after 8 hours also to let us know how much fermentation we have. Okay, so we'll be back in just a few minutes. Okay, so this is about 4 minutes and 30 seconds in. So we're going to take one more measurement before we go to checking it in a few hours. So still 4. We're already to 5 inches. And over here, we're still at 3. Okay guys, so we'll be back in 4 hours and we will record what the findings are. Okay guys, so we are 4 hours into this experiment and let's check out the measurements of all of our bottles. Okay, so bottle 1 is still at 4 inches. Bottle 2 is at 9.5 inches. Bottle 3 is at 5 inches. Let's give them a twist or a squish and check back in 4 more hours. Okay guys, we're 8 hours into this experiment. Let's measure ourselves some balloons. So in bottle 1, our balloon is measuring under 4 inches actually, so more like 3.5 inches, which is about 9 centimeters. So 3.5 inches, about 9 centimeters. Our bottle number 2, the balloon is firm and it is measuring at 7 inches, which is about 17.5 centimeters, 17.5 centimeters, 7.5 inches. And that was bottle number 2. And bottle number 3 is also firm. It's measuring at about 5 inches, which is about 12.5 centimeters. So 12 inches and 5 inches, sorry, and 12.5 centimeters. So roughly. Let's swirl each of these bottles, trying to be careful not to get any of the liquid in the balloon. I'm noticing that there's a little bit of residue up towards the top. Try to slash some of that. I see bubbles in the bottle. In bottle number 2, first bottle, I don't really see very many bubbles. I do see a little bit of yeast up that I hadn't seen in the earlier. And then this is bottle number 3, the apple cider. And I do see some bubbling around the edges, and I see some yeast is what it looks like, maybe water mixture up towards the top. So we'll see what this looks like in 24 hours. Okay, this is 24 hours after we first started this experiment, experiment 5.2. We are doing our final measurement of our balloons. So in bottle 1, we just had the warm water and the yeast. And I would say the final measurement is about 3.5 inches or 9 centimeters. Bottle number 2 had sugar, yeast, and warm water, and it still is firm, and I would say it's about maybe a little over 5 inches, so that's about 13 centimeters. And the final bottle has the apple cider and yeast and water, and it now is the biggest. So it was not the biggest for a good long time. It's now 7 centimeters, which is about 7 inches, which is about 11.5 centimeters. Okay, so that's the final measurements, and let me show you what each bottle looks like up close. So the yeast basically just kind of fell to the bottom. I've been kind of periodically doing the swirl, but basically it fell to the bottom in bottle number 1, which is just yeast and water. In bottle number 2, we have a couple of bubbles around the edges, which I think shows that the yeast probably did react. This was the sugar and the water, so I think the yeast was able to eat some of the sugar, and it caused this balloon to inflate with the gas that it gave off. And then the final, initially this was the biggest balloon inflation, and this was much smaller, but eventually this balloon went down, and this balloon has gone up a little bit. So you can still see there, looks like there's bubbles definitely going on in there. So this is still kind of decomposing and fermenting and creating the gas. You can see all those bubbles around the side, and this is still a very firm balloon too. So anyhow, that's our final experiment. So you need to write about what you've seen and all the different check-ins. I will tell you one interesting thing. I actually ended up moving these closer to my fireplace. My kitchen is about 68 degrees, and I realized that everything seemed pretty low and flat, and I wondered if maybe the yeast had gotten too cold, so I moved it closer to my fireplace, and which is when the fireplace is on, it's about in the higher 70s, maybe like 75, and that's when I saw the most improvement in bottle 3, and bottle 2 kind of reinflated a little bit. So anyway, as far as variables that might have affected this experiment, I would say potentially the temperature. I also will say that one of the things I realized in my research was that altitude affects how yeast grows in bread and things like that. So you might actually be able to make the case that in high altitudes, like here in Colorado Springs, we had a big inflation in the bottles in the very beginning. And I think you might be able to say that's because of our high altitude might have caused it to work faster than it would have at a lower altitude. So anyway, but these are our findings. Finally, after 24 hours, bottle 3 is the biggest, bottle 2 is next in line, and bottle 1 really hasn't had no change the whole time. I think there was nothing in this bottle for the yeast to feed on, so because the yeast couldn't feed on anything, they couldn't create the gas, the byproduct. So anyhow, write up your experiment and put it in your lab journal.